Hello, this is Aaron Maschinot again. This is the second of two videos collectively making up my final project for the Big Data and Hadoop class for the fall of 2015. So in my first video, I gave just a general overview of EMR, what it is and how it works. Now in this video here, I'm going to run through a live EMR example. So the problem that I'm going to be doing is exactly equivalent to homework number 3. It is homework number 3 that we went through in this class, the ratings distribution problem. And you're probably infinitely familiar with this problem already, but just in case, as a reminder, what this problem does is it's given a listing of 20,000 movie reviews by different users for different movies. It will compute basically the ratings histogram for those movies. So each movie is giving a rating between 1 and 5 inclusive, and what this will produce is this little histogram down here. How many times was a 1 movie was a 1 given to a movie as a rating, how many times was a 2, etc., etc. The results that you see here are the results that you get when you run this MapReduce program just in plain vanilla Hadoop, in other words, not in EMR. So we're about to run this same problem in EMR, and my hope is that we get exactly the same results. So I will be using S3 in this demonstration here for our to load my data, to hold my data, and to write data to. So let's get to it. Okay, so first let's go to the AWS Management Console page, and let's start off by first going to S3. Okay, so here is my folder that I've created. Let's go on into it. Now, when you run programs, MapReduce programs in EMR, most of them are going to have the same common sort of 4-folder structure that you'll want to set up if you're using S3. Those 4 folders are input to hold input files, jar to hold your jar files, logs to hold the logs that are going to be written during the actual EMR test, and output where output files from the MapReduce code will be written to. So let's just go into each of these to show you more specifically what's in them. I'm inside the input folder now, and you can see what I've done is I've taken the total collection of 20,000 lines, ratings, and I've broken it up into 5 evenly split data sets here that collectively make up the entire data set. This is done so that, as done in class, we can run 5 different mappers here. If you click on one of these, the U1 data one, just to show you what's inside, make sure we're on the same page here. Let it download. Okay, click on that. Let's open up this file here. And sure enough, this looks as expected. So each line here is a user rating. The first column is the user ID number. The person who's rating it, that is their ID number. The second column is the number of the movie that they're rating. The third one is their actual rating, 1 to 5 inclusive, and the fourth one, which we won't be using at all in this MapReduce code, is some timestamp, but we won't be using it. And there's 20,000, or 1/5 of that, so 4,000 values listed in here, or I believe that's right. Okay, so now let's go. Oh, the other files are set up similarly, so let's now go back to look at the jar file. The jar file, sure enough, is holding the jar file. The jar bucket, I should say, is holding the jar file. So this jar file here is a 100% equivalent. It is the jar file that I submitted for homework 3. I haven't modified it whatsoever. Yeah. Okay, so logs right now are empty. This is where the framework, the EMR framework, will produce logs when we do a run and put them in here. And then finally output. Output itself is currently empty. The MapReduce outputs will get put here. Okay, so now we've explained the S3 setup. Let's now go and launch an EMR the EMR service itself. Okay, so we're back at the AWS homepage. We don't have to set up our cluster manually through EC2. The nice thing about EMR down here is that EMR will do all of this for you. So let's just go straight to the EMR console. Okay, so here we are at the EMR homepage, the EMR console page. And as you can see, I've run through this rating distribution problem a few times to test it out, make sure I understood it. Let's now do it live. So let's go to click on Create Cluster. Okay, so they offer you some basic options to set up here. Let's be a little bit more advanced. Let's go to the advanced options, which will give us more power to set things up. Okay, so here we are, software configuration. You can see inside of here, if you click on the releases, they've got 3 different releases in the 4 series. There's also earlier versions, but remember, prior to EMR 4.00, they referred to them as AMIs. We're just going to be very straightforward. Let's just use the latest 4.2.0, that release. Okay, and then you can see down here, these are the various libraries that will come pre-installed on our instances when we for this release. Now you can see Hadoop's going to come down, Pig, Hive, and Hue. For the purposes of this basic MapReduce program, we won't be needing Pig, we won't be needing Hive, and we certainly won't be needing Hue. Really all we need is Hadoop. We're just going to be using HDFS and Yarn. So we'll just leave that on there. We're going to leave the software settings the same. Let's just go down to add steps. So now at this point, you could add a step here to do something. This would be your actual MapReduce task that you want done. But I'm not going to do that at this point. I'm going to leave this blank. And what I'm going to do instead is fire up the EMR cluster, have it all loaded up, and then from there I'm going to launch my my job, my task. Let's go ahead and do that. Click next. Okay, hardware configuration. We'll leave the network and subnet alone. Those are beyond the scope of this talk. But setting up the various nodes used in the cluster, that's something that we'll aim at here. So we're going to set up the instance type. There's 3 types of nodes, remember, the master, core, and task nodes that one might use when they're doing EMR. So for the master node, let's take the advice of Amazon and set it to just M1 large, and we only need 1 of those. For core nodes, let's also, this isn't a very computationally challenging problem, not memory challenging that we're trying to solve here. Let's also set those to M1 large. And we're going to have 5, we would like 5 mappers to be running at the same time, so let's generate 5 core nodes here. For task nodes, we've only got 1 job that we're going to be running, and there's really no need for task nodes. We're not going to have to increase or later on decrease our computational power, so we'll just leave that at 0. So we won't be using any task nodes at all in this example. So click next. Name of our cluster, let's call it ratings distribution. Okay. Logging, we've already set that up. Or no, we haven't set that up yet. I'm sorry. This is where the log files will get produced at. So let's go on in and set this to logs. And click select. Actually, let's change ratings distribution to rating distribution 9. So now we've set up our log folder here. We won't need any tags. We won't need any bootstrap actions or anything like that. We're going to be fine with just the default libraries that get installed in release 4.2.0. So let's click on next. We don't really need a key pair here. This problem's so minimal, there's really no reason to go on to SSH into the master node or anything like that, so I'm just not even going to do it. We don't need to worry about security encryption, it's just too minimal of an example. So we're done. Let's just click on create cluster. Okay. So our EMR cluster is now being created. It's now being set up. And you can see that we're now in the state of starting. So ratings distribution 9, is starting up now. So while this EMR cluster is setting itself up, I'll just go through at a high level some of the details that you can look at down here. So everything's still being set up. A lot of this stuff isn't ready to go, but you can see it's trying to provision resources here for one M1 large master node and 5 M1 large core nodes. Sure enough, no task nodes are being set. If you scroll on down, they've got some monitoring things that you can look at, but nothing's really set up yet just yet. So these are kind of very little use, really no use until we get our cluster set up. You can click on hardware, which kind of just repeats what we've already shown at the top. It's setting up the core and master nodes, 5 core, 1. It's still provisioning resources for both. And if you go down to steps, you can see, sure enough, at this step, it's just setting up the cluster. There's nothing else to do at this point. There's really not much to look at just yet, so because everything's still being provisioned. No, we're not doing any bootstrap actions or configuration, so we'll just go back up to the top now. And so we'll kind of wait this out at this point. It usually takes a handful of minutes for the cluster to be fully provisioned and set up. And so what I'm going to do at this point is stop the presentation, or well, I'll let it continue, but I'm going to just clear out the time that we're waiting so the user doesn't have to wait for this to fully load up. So I'll come back once this is fully provisioned and set up to go. Okay, we're back. So the EMR cluster has been now fully set up. You can see that the cluster has evolved state to the waiting state, meaning that it's now waiting for us to enter any jobs, or if not, to terminate it. You can see over here the master, we've got one M1 large instance now running for the master, and for the core we've set up 5 M1 large. You can see, I didn't really point it out, but I'm operating on I'm working out of the Northern California region, which is where I live. I'm in the Bay Area. And you can see the availability zone. It's picked one out for us here within that region. EMR 4.2.0, everything's set up as should be. Good. So let's now go ahead and run our actual MapReduce task. So let's go to add step. Okay, we're going to leave it as a custom jar. Okay, custom jar. What are we going to call it? Let's just call it ratings distribution. Okay, we now need to tell it the location of the jar file itself. So we'll navigate to there. There's the jar file we'd like to use, so select it. Now, in the arguments box, this is where you would put any command line arguments that your jar requires. This particular jar requires 2 arguments. The first argument is the location of the input files. The second argument is the location where the output should be put. So you can see I've just put in the required arguments here. Both of them are using the S3 URI, so we can just get the data directly from S3 and push it right into our EMR cluster. Very nice little option there. For action on failure, we'll just continue. Hopefully that's not relevant here. Let's just click add, and as soon as we do, the job should start up now. So let's click add. Okay. Okay, so it doesn't look like much has happened, but if you scroll down, good, you can see now that under the steps category, we've now got another step that has been added, ratings distribution. It's pending. No logs have been created yet. This step tends to go pretty quick, but while it's running, I'm just going to once again quit this, or let it run, and then I will remove this so that you don't have to wait for this thing to go through. I'll come back once the job has finished. So let me scroll to the top, and I will come back. Okay, so the job is now finished. Let's go down and check out what has happened. So if we go down to the steps section, you see the rating distribution. Now we have log file output. We can click on the system log, see what that looks like. Looks like typical system log here. You see at the bottom here, bytes written 39. That's pretty much what we were hoping for. That sounds like it's about the right size for this particular reduce file. Standard out. Take a look at that real quick. The only thing I had in my standard out was I was echoing back out the input and output files. Those wrote. That's good. Let's go look at the go into the jobs itself. It says completed. That's good. It means it's done. And you can see on down here there were indeed 5 map tasks that ran. They all completed and 1 reducer task. So that's good to see. Let's see, is there anything else of note here? I guess you could spend a lot of time going through things. Node status. If you look on number of active nodes, well, that's not showing up for some reason. Well, I'm going to go ahead and show the, since this is being recorded, I'm going to go ahead and go back and look at the actual output. So if everything worked as hoped, we should go back to S3 and see what the final results are. So we're back at S3, which is where we hit our results right to. We go on in, let's check out the output folder. Good, there's output results have been written. And there, as you would expect, there's the success file that Hadoop always writes, and the part file for a 1 reducer case. Let's download it and take a look. Okay, that looks pretty good. And for direct comparison, let's go back and compare it to what we were expecting. So you take a look. 6,110 is what the Hadoop results gave. Ditto for the EMR results, and it looks like all the rest of them match too. So this was a successful run of EMR. It produced the correct results, and that means it worked. So one final step before I end the video, and that is to go back to EMR and recall that since we made our cluster long living, it's up to us to actually terminate it, or else we'll just keep getting charged for having having used these resources or claimed the resources. So I will go ahead and terminate it, and termination protection is on by default. Let's turn it off, check it, and now we should be good to go to terminate the cluster. So now the cluster will be terminating, and that means that the data, any data that was on it, would be gone as well. But we've already copied all of our results back out to S3, so we're done. So anyway, that ends my demonstration. I want to thank you for a very nice class. I learned quite a bit in it, and thank you again.